Howdy, I'm Ashley Helton. Welcome to this episode of Easy Go Garage. Today I'm in the shop taking a look at open circuit voltages on some of our golf car battery packs. So I got to thinking this would be a good time to take a tour of our on-site battery lab. We can have a look inside the batteries to see what makes them work and what makes them fail. Let's head on over to the battery lab and talk to one of our engineers. Hey, Darla, how are you doing today?
I'm great, Ashley. How are you?
I'm doing fine, thank you.
How can I help you today?
Well, I was hoping you'd show us around the battery lab and maybe even autopsy some batteries for us.
Oh, that would be great. First, we get the batteries in from the customer. We put them on to test, and we try to run them for 10 cycles or so and see how they run.
Meaning we have to charge and discharge them several times?
Exactly. Each cycle, we gather information such as specific gravities, voltages, run times. This information usually points us to a weak battery in the set. We test all battery types and technologies in this lab.
So show us a little of your routine on gathering test data while cycling the batteries.
Sure, it starts with a visual inspection of the battery.
Manufacturing information such as date codes, right?
Yes, date codes are usually found on battery terminals and are identified by a letter and a number, but this varies between manufacturers.
Now, modern-day golf cars have controllers that record the amp hour usage of each vehicle. So when a battery set comes in, do you make sure that the technician records those amp hour readings?
Yes, those amp hour readings are very important. Each golf course and individual uses their cars differently. It's important that we know how the batteries were used before they get to the battery lab. We document on-charge voltages and specific gravity readings. I have my hydrometer here. I'll show you how we do it.
That's a cool hydrometer you got there.
Yes, it is. It works really well as long as you keep it clean, and it'll last a long time as long as you don't drop it. Let's check this first cell.
You say you always take these at full charge. What do these gravity readings tell you about a battery?
They'll give you the general health of the battery. They'll tell you if the battery has been over or undercharged, has a dead or shorted cell. The levels will vary by the age of the battery, by the state of charge, by the frequency of watering, and they'll even vary by battery manufacturer.
But these gravity readings won't give you a true runtime of the set. You have to hook them up to a discharge machine, right?
You're exactly right. The discharge machine to give us the most accurate reading.
I've used one of these before. You connect the machine to the set, and during the discharge process, the machine applies a load on that battery set, and it times how long the batteries take to get to a certain preset voltage. This is what we call battery capacity.
When the machine stops, we look closely at any batteries that drop below normal. These are weak batteries. We'll take these batteries and perform an autopsy where we cut the tops off and give a thorough inspection of the interior of the batteries.
So why autopsy? What does it tell you?
It helps us to validate battery suppliers, to evaluate chargers and algorithms, to troubleshoot field issues, and to support warranty claims.
So for the autopsy, do we have to ship the batteries off?
Oh no, we tear them down right here in the other room. Come on, I'll show you.
I got dibs on the saw.
This is where the magic happens.
That's one heck of a saw you got there, Darla.
It's brand new. We can cut an entire set of batteries in one pass.
What's the first thing we need to do to get started?
First thing we do is we dump the acid from the batteries. Hey Ash, why don't you grab the face shield and gloves and we'll get going.
Let's do it. Now that we're up on the table, Darla, walk me through this.
You're going to take the cap off of the battery, slowly tilt it away from you to drain the acid out of it.
Yeah, you don't want to get any of that on you.
It wouldn't hurt your skin too bad, but it'd sure mess up your cotton clothes. Now that we have it drained, it's time to cut the tops off with the saw. You want to do the honors?
You betcha.
We have the cover off, we have the wells broken. I think it's safe to take that face shield off now.
Ooh, I'm sounding like Darth Vader with this thing on.
So let's take a look at the inside of the battery. This is a positive terminal, and this is a negative terminal. The positive plates are attached to the positive strap. The negative plates are attached to the negative straps. The current flows through the electrolyte from the negatives to the positive, from one cell to the next.
And so each cell is connected in series, right?
That's right. 2, 4, 6, 8. We got 8-volt battery here.
So how do we tell if we have a bad cell?
Well, let's take one out and have a closer look at it. All right, let's take a look at this cell. If you'll peel back that negative plate and take a look at that positive. We have some shorts through that positive right here. You can see on the separator and on the positive plate where we shorted out some. This positive plate swelled and cracked the grid frame. So let's go on down to the next negative and see what we see there.
Looks like a lot of deterioration, Darla.
It does look like a lot of deterioration. And that deterioration is due to, can you see this line right here?
Stratification line?
That's right. We had our fluid levels got below this line and deteriorated the separators and got the battery really hot above that line. You can see the mossing starts above the line, that everything points to poor maintenance on this battery.
So what other types of failure modes do we see here in the lab?
Basically, there are 3 types of failure modes. There are maintenance issues such as we saw here, there are manufacturing defects, and there are just old age, just used up. You've just seen a good example of poor maintenance, which is failure to adequately water the batteries. Other issues we see are terminals melting due to corrosion or loose connections. Manufacturing defects we see most often are damaged plates or separators. We also see some poor welds.
Darla, thank you for having us over at the battery lab and showing us how to do an autopsy. I hope you learned something because I know I did. See you next time on Easy Go Garage.